try that again. Thank you, Peter, and thank you everyone, and thank you, Bears, for giving me the opportunity to talk. So, I wanted to talk about serverless JavaScript. So first, I wouldn't mind getting a feeling of the audience. If you don't mind doing hands up or something for a poll. Who here has played with Node.js? Wonderful. Good. Who has played with cloud technologies? AWS, Azure, Google? Wonderful. Good. Okay. Who is currently building or has played with Lambda? Okay. Some. Okay. So, I'll tell you a little bit about myself then. Who am I? So, well, I've been introduced already, but I'm in Meldrum. That's how you can find some stuff about me. That's an artist representation kindly drawn by my daughter, Ollie. A little bit about me in JavaScript. I do indeed love JavaScript. First website I built and was paid for while I was at university a very long time ago, I'm afraid. And Netscape 2 was around 1994, I think. And I've been building websites ever since, and absolutely still passionate about JavaScript. And this talk is hopefully my assertion that JavaScript is going to take over the world. So let's see if I can persuade you on that. Oh, and yes, my favourite old El Paso is the taco shops, rather than the flower ones. They're far superior. Okay, so yes, I will talk about a little bit what serverless is and why we might care. I will talk specifically about Lambda. I apologise if it seems like an advertisement for AWS. I know there are other clouds out there. It's just the one that I've been working on the last couple of years, so it's the one I know. I suspect anything I talk about here would transfer to Azure or Google Cloud or OpenStack. So I'm going to talk about why I believe Node.js is the best choice and why it is. And I'm going to show you hopefully a few options for how to build and deploy using JavaScript. If I get to some of the code, and if you're interested later, you can find it on my GitHub. My address. So, what do we mean by the word serverless? Function as a service is FARS. So, we might use, let's say, AWS Lambda, Cloud Functions in Google, Azure Functions, or Quinling in OpenStack. But it's quite simply, I've got a function, I'm going to chuck it in the cloud to be executed. That's generally what we mean. When we say serverless, we might mean the serverless framework, because they very cleverly branded that word for their own framework, which gets quite confusing. Or we might also mean managed services. So again, in the AWS world, Cognito for authentication, Dynamo for databases, SNS, SQS. They've even rebranded GraphQL and called it AppSync, and they'll rebrand everything and created a managed service themselves. These have very similar benefits to servers and functions as a service. Okay, so how did we get here? Little history of the web. So here we have one of the most interesting lines is the red one. 1990, everyone knows what happened in 1990, the World Wide Web was invented, and in 5 years we got, I'm going to count the noughts, 3 million websites. And then we have another 10 years, it's the same graph, but from 1990 to 2010. That graph was an amazing exponential growth. Now it's like this little dot here. And instead we got another exponential graph to 2 billion. And if we look at another 10 years on, again, that seems like a little dot. We're continuing to go up and up and up and up until we get to about today, where the scale of the red ones on the right, by the way. You can see we might possibly, we've got about 1 or 2 years to data, we might possibly be leveling off in terms of numbers of websites, but huge exponential growth. Clearly that means JavaScript is a very important language, as is the lingua franca of the web. So if we wanted to run a website, how would we do it? In the olden days, we would have to do it all ourselves. We might have a server room, and we would buy our own hardware, manage it, Install the operating systems, the services, the patches, deal with network attacks, everything myself. And I remember building things like this and you know, jokers, make sure you don't keep the power supply on the way out and then your website goes down, and indeed that has happened to me. So instead we built data centers, maybe moving sort of late 90s now or something, 2000s, and instead we could put things in a data center. And now we have really reliable power, we probably have a much better internet connection, connected to the backbone. But still, we're buying our own hardware most of the time. We're dealing with our own operating system patches. It's very, very expensive, very painful. So, into the cloud. 2006, AWS was born, so around here. Just as the previous graph that I've added the Amazon share price in. You can kind of connect that to the rise of websites. And you thought the rise of websites, number of websites was rising exponentially, and Amazon's share price just dwarfs it. So that is really scary. We start thinking about the megacorps of Amazon and everyone else, but still, we're pretty embedded to them. So, 2006, EC2 came along, first thing, but for 5 years or so until 2010, it was just EC2. So that means we're providing you essentially a virtual server in the internet. So you don't have to buy your own hardware anymore. You still have to install your own operating system, deal with your patches, deal with a network attack, deal with almost everything. It's just like a fancy VPS with some orchestration around it. Around 2010, I recall you got AWS++, I call it. So they started to bring some really clever orchestration services around, elastic load balancers, RDS for hosting your databases, and we're starting now to make it much more viable. And at the same time, Azure and Google come along into the picture. And as the cloud gets more and more important, of course, this Amazon share price does not have AWS split out, so this is Amazon.com as well. So, you know, it's just for interest. But around 2015, Lambda comes out, and Google acquired Firebase. This was only about 2 or 3 years ago now, 4 years ago. These things come out, and again, change the picture again. Again, just to underscore the huge importance and growth here. If you compare these revenue and growth figures, looking especially at AWS and Azure, these numbers are really quite phenomenal. With that kind of growth on that kind of revenue, we have to take notice of these things. But I'm sure as you all your hands up and you're working on the cloud, you know that. The Google figures are just rubbish because they don't reveal anything, so who knows what they're doing. So, yes, serverless. Some of the benefits of serverless we talked about. You don't have to deal with hardware, operating systems anymore. Sometimes not even have to worry about your own services. You pay as you go, and you potentially have lower effort horizontal scaling. Not necessarily, but that's certainly how it's sold anyway. So, I believe serverless is very, very important. I didn't ask, the other question I was going to ask is anyone building on Kubernetes? And of course, there's the two big things at the moment, right? Okay, right. There's, yeah, and it was, you know, very interesting stage we're at to see, you know, whether what will win or whether they will both exist and serve different purposes. But I think in the IT industry, we're at a very interesting place at the moment. I believe we're at a tipping point. Sure, if we've all worked in the industry for a while, we understand these kind of things. I love this quote by Dijkstra. The computer scientist's main challenge is not to get confused by the complexities of his own making. Right? We build a lot of code, and then we really struggle to maintain it and live with it. Less code, the better. The less things we personally have to invent, the better. This is one of the reasons why I think serverless, and particularly what AWS are doing, but what all the big players are doing, is very interesting. In the olden days, to buy off-the-shelf software solutions was a recipe for disaster. I'm sure you've all dealt with it, integration nightmares. Nowadays, with the kind of services that people like AWS and the others are providing, it's now become a no-brainer to use them. They integrate so well, they work at an API ecosystem level. And more, I believe we're at a tipping point where these services are going to become so good, we are not going to have to create so much code and so much complexities of our own making to provide it. I believe this means, while we in the software industry are disrupting every other industry, we are going to be disrupted ourselves by this. And I think that's really worth taking note of, and AWS is, I think, is at the cusp of that. Okay, so yes, JavaScript. Should it be JavaScript in the cloud? Well, again, these numbers are taken with a big grain of salt. But still they tell a story. They tell a story. You'll all know that JavaScript is very, very widely used. Of course, that's because of the internet, but I like to think it's because it's awesome too. Okay, so down to AWS Lambda. What is it? As we said, it's a service that you can upload a function to AWS. But what's the point of having a function in the cloud? Unless it can be triggered. So the whole point is you then hook your functions up to be triggered by events. I'm sure you've heard of these various things or worked with them. They're separated like this for a reason. This top plot, things like API gateway, to create itself an web API, and all the others, would be a synchronous event. They will trigger your Lambda, they'll wait for it to finish, and they will do something with the response. Right? The API gateway example, they will bung it back to whoever called it. Right, the browser usually. This S3 or our CloudWatch event, which is just going to be like a cron job kind of idea, is asynchronous. They will trigger your Lambda and then don't give a monkeys what happens to it. So far and forget. And this is much more, the DynamoDB streams or Kinesis is a streaming technology, so this is a polling. That's nice. This is also asynchronous, but instead you hook up your Lambda to constantly poll these things to see if there's something waiting on the stream. So you've got these three different ways of triggering your Lambda. What's the signature? So lots of people, almost everyone will know, so you'll be very, very familiar with the idiomatic node signature of providing a callback. So the first argument is an error, the second is your response, as it says there. Or you could use the funky new async example where you can just return a promise or a synchronous value which will be wrapped in a promise, or an error, which will have the same effect. Okay. So, how do Lambda? You write your JavaScript code. Yay! Don't forget the semicolons. You package it up. You make a zip file. You can use bundlers for that, or you can literally just make a zip file. Just stick these two JavaScript files in there. And then you might upload your package to S3, but you don't have to. And then you make some function call to create your Lambda, passing it to code. Great. So let's do it. So, I've got a few of these videos. I'm not make a judgment call on how many is worth showing. I'll explain what's going on here. So we just created a role there. So that was all functions need to run under a role to know what they're allowed to do. Okay. And here we go. Here's our very simple function where we call hello world. And then we zip it up, and then we call create function. So we specify a name, we specify a runtime, we can use node 10 now, which is great. We specify a role, we give it the ARN, Amazon resource name, the unique name for that role. We specify the handler, that's the JavaScript file index and the export handler. There we go, we've created it. We can now invoke it and see what was created, and there we go. Return hello world. So sequence was shortened, but that was how simple it is to actually get your stuff working. All right. Worth going into this stuff. So there are some limits. Some of the interesting things is you can only operate for a maximum of 15 minutes. In most use cases for Lambda, that is more than sufficient. And I think to think about is concurrent executions. So the horizontal scaling of Lambda is every time someone or an event is triggered for your Lambda to call, a Lambda will be created magically by AWS, presumably using containers somewhere underneath it, or probably Kubernetes, or something similar, to provide you a function. Right? If that function is still being executed, so that process, that node process is still running, single-threaded, and another Lambda event is triggered, you'll get another Lambda. So you get concurrent executions. So you try and keep your Lambda small, but that's how you get complete invisible horizontal scaling. If that function is completed, it will hang around for 10-15 minutes, so if another call comes in, that will immediately come back. And that's what you get the difference between warm and cold start discussions going on. Okay. So when did my talk start? I forgot to do my stopwatch, but I can use this clock to see how long I've been going on
You've
for.
got another 20 minutes.
20, okay, so max. Okay, great. So, I'm sure we all know this, underscore the importance of infrastructure as code. This is the AWS console, very useful for exploring AWS or for dealing with problems in your cloud, but we never ever change anything here. Not on your real system. Do it on some test accounts or whatever. The very, very important thing, like automated tests, is automated infrastructure. We need it to be repeatable. We need to know what it's about. So we write infrastructure as code. More traditionally, configuration. There's a big debate now going on. Should we use configuration or code? That's some of the stuff I'll go into now, are some of the options you've got. So you saw an example of using the AWS CLI. Command line interface, you could just do that. You could just build your own resources doing that. But very quickly you'll find it gets too complicated. So we want to have a framework on top. There are some of the frameworks. AWS provide CloudFormation. Define all your resources in YAML configuration, and then just go tell CloudFormation to build them for you. The other big competitor is Terraform. Terraform is also configuration, but in HashiCorp's configuration language. A lot of people are a really big fan of this. One of the major differences between Terraform and CloudFormation is in terms of workflow. CloudFormation, if there's ever a problem, it rolls back everything it tried to do. This can be very slow. Terraform works directly against the SDK and has a roll forward mentality. If something breaks with your Terraform configuration, it will tell you what's broke and you could just rerun. Change your configuration and rerun. So a lot of people spell that as being a good plus of Terraform. Terraform is also what they call multi-platform. So you could provision resources in other clouds as well. Serverless framework, built on top of CloudFormation, but by some other company, and provides nice extra stuff on top of building serverless and Lambda, basically. New one on the block, so all of those were configuration based. Cloud Development Kit is the first one that I think is going to create a very important change to how painful these kind of tools are. Because this, you can define all your resources in JavaScript. And I'll go and show you some of those in a bit. And some of the problems with CloudFormation is that it's not very reusable. You can build up these resources and they're one-time use. You get a lot of copy and paste of thousands of lines of YAML. The fact that you can do it in code, the CDK, it's brand new though, is very powerful. It gives much more reuse. And there's lots of others as well. Some of these are much more opinionated and focused on a certain small set of resources. This is Netlify, Cloudia.js, Zeit now, and Scepter. Mostly about providing sort of small to medium, but very opinionated websites with almost zero configuration. So you just want a static site with maybe a couple of serverless functions underneath it. Use these and it's no work at all. And there's loads more as well, which we'll get to. Okay, so here is an example of an S3 Lambda trigger. So maybe someone puts an object into S3, Lambda won't be triggered, and it'll go do something and maybe create another S3 back. I was going to show you the code for that, but I think I will move on because I probably wrote too many examples. So, yeah. Yes, let's have a look at this one. So this is instead perhaps something you're more familiar with. You're creating a web API, very typical use case. So we might have a website, call it Goggle, right? And it might call an API gateway. These are HTTP endpoints, and they will then hook up to Lambda to go do something. So let's look at how you might do that in CloudFormation. So let's see if I can do that. So that was, let's look at this one. Can you see all that? Hopefully that's big enough. So here we have, this is a cloud formation, but also called SAM, the Serverless Application Model. So we are defining some resources. You can see we have defined a serverless function, and very much like that CLI, similar things there. Where the code is, what it wants to run in, and we're connecting it to a gateway. So it's an API based on the /hello get. And then we specify our gateway, and we can specify that in Swagger, which I won't go into. There we go. So you can see YAML, not too complex, but it does get, as the resources grow, it does get more and more complex. So how might we run that? We create an S3 bucket. There we go. And the sequence is shortened. We call SAM package, which basically does the zip file thing. And then we call SAM deploy. And that will go off and go and create a CloudFormation stack. There we go, it's done. I'll show you this one. Yeah, that's fine, I'll show you that one. So, we now have to find out the API. We have another one where we do this automatically, but this is interesting. So we can go to the stack, see the resources created. That tells you the web API that we just created. So I can change it in here, which is a test, to just literally curl it. And run that, and there we go. Hi there, Mask. So that showed the creation of it. All right. I'm showing it in the browser too. There we go. So that's CloudFormation. Okay. Serverless is very similar to that, except it does some of that stuff like the zip file all for you. I will skip showing you that. But again, if you want to see all the code for all this, it's on the GitHub. So serverless will look very similar. You can define CloudFormation resources by default in your serverless YAML as well. So it's just a little bit of icing on top. Terraform looks very different. Have a quick look at this. I'll just leave this running while so you can see some of the Terraform code. Again, it's configuration. On first looking at it, you would probably that's the handy index. So that's what some Terraform might look like to define your gateway. Yeah, I'm sure it's great. I kind of sigh when I see that. It's definitely another thing to learn. Please just give me it in JavaScript. So here's Cloudia. Now they will give you a more JavaScripty solution. Let's just quickly show you this one. Because this shows literally starting from scratch, creating a directory, installing Cloudia, and creating a web API. If you see, there we go. So this is your index.js. Looks much more like Node Express there, because Cloud is giving you some wrappers around it, so you can just get to the request. There we go. On API.get, we'll say hello world, basically, or hello whatever you call it. And that's literally all we need. We don't need any config, don't need all those API definitions. Instead, we can just call Cloudia create, tell it where to create it, tell it to web API, and it will go and do it for you. And I sort of wanted to show this to see if people wanted to get into serverless, just how easy it can be using some of these tools. Netlify is another very popular one that works very similar. Cloudia also has great tools for hooking up to things like Alexa or Lex if you want to build chatbots or Alexa bots or anything like that. And again, it's almost as simple to create your Slack bot using Cloudia as well as creating a web API. And there's the test. Pretty. Not very interesting doing a car, but that went off to the internet and did something that we just built. Okay. So, a lightning tour of some of the ways you might want to deploy these things. Here's some of the others that I didn't really talk about, not had much time to talk about. Someone just tweeted me about Pulumi, and yes, I think Pulumi is a very, very interesting one. It's Terraform-like, so it's going to work directly against the SDK. Good things about this, it rolls forward instead of rolling back, so you can fix forward. It's not web-native CloudFormation, so it's faster, but Pulumi, you can define it in code, not configuration. Well, I think Pulumi is one of the most interesting things coming out. And then, as I said, the CDK I think is also very interesting as it can be defined in code. It is against CloudFormation though, so you pick your poison. If you're wanting a smaller scale, go pick one of these, Netlify, Zeit, Semicro Architect, based on those particular opinions of those tools that you like. Right. So, what am I doing for time, Peter?
You've got 10 minutes including Q1.
Oh, okay. Well, I'd like to just spend a couple of minutes talking about the CDK then. As I was trying to say how JavaScript will take over the world, obviously JavaScript's on the web, showing how JavaScript can actually run your production code in Lambda. And here using CDK we can show how JavaScript can provision your resources too. So we can have JavaScript literally everywhere, no other languages needed. Great. So I did this just this afternoon, so literally 2 hours this afternoon. I've never picked up the CDK before. It's a really in developer preview though, lots of signs on it saying do not use this for production. But it's coming on very, very quickly. So here's a potential serverless architecture you might build. So this is my new recruiter app. This is, if you guys have built on AWS before, I'm sure you've seen these sort of cloud architecture diagrams before. These black things are lambdas. This is an S3 bucket, this is an API gateway, and this is DynamoDB. That's all I managed to build, so I won't bother talking about the rest. So the idea is a candidate will upload their CV to S3. S3 will trigger a Lambda to analyze that CV, and then create a record in the candidate database. As soon as something is created in the candidate database, a Dynamo stream will trigger an email clerk to send an email back to the client and to some recruiter to say, yeah, there is something like that. And then a candidate can then go and use the API gateway to get their candidate profile, which will then go and call the Dynamo database. Now that can seem like quite a complicated application. Literally, I'm no genius developer, and it took me 2 hours to build the whole thing. So let's just see if I can. I'll just show you how some of the code can looks. If I can. No, that's not that one. It's this one. No. Is it this one? Yes, it's this one. See if I can move this over here. There we go. Okay. So here it is. It's a node package. You can see we've got match more dependencies because you choose which of your resources you want to hook into the CDK. So you have a CDK.json, which just tells you where your infrastructure initialization goes. If we look at that, I mean, this is not particularly interesting. Basically, you create a class called your init stack, and then you can refer to any, I call them services, but whatever modules you want to call. So if we, go to candidate services, here is how I provisioned everything. So, it's 80 lines, but literally this is all I needed to build, apart from the actual Lambda code itself, which I'll show you, to provision. So what have I got? A bucket, the CV library, a Dynamo table. Look at this, all beautiful JavaScript. No HashiCorp or no CloudFormation involved. All this will generate over 1,000 lines of CloudFormation. Here, I've created three lambdas: the candidate profile, which is the API gateway, the analyze CV lambda, and the email clerk. Just specifying these handlers here. And I specify some positions. I don't have to worry about all those complicated role, trust JSON documents. I can literally just say grant, read, write, grant, read, whatever. So I think this is bringing the power of AWS into developers' hands. You don't need a platform team. This is my dream as you go forwards, as you use all this stuff. There we go. So this is adding event sources, how we hook it all up. There's a Dynamo event source to turn the stream email clock to the stream, etc. So, and there we go. There's the API gateway with some Lambda integrations. So that's literally all needed to do from an infrastructure point of view. And then there's the Lambda code. I'll just show you one of these maybe. Analyze CV. So this is expecting an S3 object, where I then go off and use that key to go and get the object. I assume it's some JSON. Obviously, in the real world, this would be some horrible Word plugin to parse someone's Word document and then look for keywords that say cloud and then mark the skills as a cloud architect or something, right? But all I'm doing is assuming it's a JSON document, sticking that in Dynamo with a name against it. Okay, so hopefully we can actually see this working. And then I'll wrap up. So, yes, we have a test JSON. Okay, so who's the name of our candidate? Hang on. Oh, okay, Joe. And their skills is DWA and awesomeness. How about that? What if I could spell awesomeness? Okay. So that's our test JSON. You can see above there. There we go. So I will upload that to S3. Now, obviously, I haven't built a front end. The idea was there was a front end that would do something like pushing the CV and upload into S3. Didn't do that bit. So this is simulating that. Let me cross our fingers. Well, I uploaded it. And this would need you to see my email. Maybe it's worked. My phone's buzzed. Let me show my email over here. So there we go. Welcome, Joe, to the best recruiter ever. We have set your skills to be DWA and awesomeness. So they got an email. So that actually ran through all that infrastructure of going Dynamo stream to an email clerk using SES. So I did set it up as well, which is Amazon's simple email service to send an email. And indeed, we could then, it's probably too small for people to see, isn't it? But use the web API by name, and hopefully, there we go. That's the JSON down as well. So obviously hooked up with the front end. So that's the recruiter app, hopefully showing you how utilizing JavaScript, even in your infrastructure, can allow you to create quite complex apps very simply. All right.